2 to 3. 2 to 3, and that's cups of water to cups of flour, right? Okay, so what can we write in the first row of our table, Dewey? 2 and 3. How do I figure out what to put in the second row, Michaela? Multiply by 2? What do you think, Ricardo? Add 2. Now how about flour? Oops, sorry. Thank you. Add 2. And what about for flour? Add 3 and I get 6. Now, 2 times 2 is 4, but here's why we're not multiplying by 2. Because here, if I add 2, I get
6.
If I add 2, I get
6.
If I have multiplied by 2, I would have gotten 8. Right? We're adding as we go down the table, we add. As we move down the table, we add. So we add 2 at a time on the left and 3 at a time on the right because that's our ratio. Okay? So let's count. Tell you what, when I point to it, you tell me what goes there.
9.
Good.
8. 12. 10. 15.
Awesome. Okay. So are all of these values or all of these ratios equivalent?
Yes.
Julia? Yes, they are. How do you know? Because they're all multiples of 2 and 3. Good. Rocco? Yes, go ahead. On the shelf. Okay. How else do we know that these are equivalent ratios, Sasir?
If you use a T-chart, you will see that.
Is this the same thing as a T-chart right here?
Yes.
Yep. Because our ratio table is very similar to a T-chart. The only difference is, with a T-chart, the relationship is X to Y, input to output. Right now, we're talking about the relationship of X to the next X, or Y to the next Y, right? Which is plus 3 over here and plus 2 over here. Yes, Devin. Go ahead. You can get one out of the blue bucket. Okay. So what's the value of the first ratio, 2 to 3? What's the value of that ratio, Jordan?
2 cups and 3 cups of flour.
Uh-huh. What's the value of that? Yes, sir. Mm-hmm. 2/3. Yep. We could say we use 2/3 as much water as we do flour to make paper mache. What's the value of the next ratio? Vivian. 4/6. So are these two equivalent? They have a different value.
Yes.
Ooh, Leilani. Leilani says, but it's the same thing. How do you know? She's like honored. Because it's equivalent to the other fraction. How do you know? How do you know?
If you add 2, it's 4. If you add
Uh-huh.
3, it's 6.
Yeah, so we're sticking by the rules of the ratio. So they had better be equivalent if they're in the same table. Jordan, that's enough. Stop. So what about 4/6? Can I write it differently? Liliana? What's that? Yes, how can I write it? How can I rewrite 4/6 in a simpler form, Tony? Mm-hmm.
2/3.
Yes. I can reduce it, right? What's the value of every single ratio in this table? Kalia? 2/3. How do you know that? They're all equivalent. If ratios are equivalent, they have the same value. Good. Okay, go ahead and turn the page. Example 2 on page 38. Javier has a new job designing websites. Nice. Okay, let's learn a little bit about his salary. He's paid a rate of $700 for every 3 pages of web content that he builds. Create a ratio table to show the total amount of money Javier has earned in ratio to the number of pages he has built. So, can ratio tables only go up and down? No, clearly. We can also go from left to right. Okay? So what's our ratio? We have pages and money. Julie, what's our ratio?
700.
Okay, what if we're talking about pages to money? 3 to 700. So what's the first thing I can write here, Moser? 3. And if I write 3 here, what can I put here, Dewey?
700.
700 what?
Oh, 700.
Right. So Javier is saving up to buy a used car that costs $4,200. All right, Javier. How many web pages does he need to build before he can pay for the car? What should we do to figure this out? How many web pages will he need to build? Michaela, what do I do? Add what? $703? What would that tell me? If I add 703, I'd have 703. Oh, I see what you're saying. Add 3 here, and then add 700 to get this value? Yes, ma'am. What's 700 plus 700?
14,000.
Columbia, give me 5. Okay. I will call on you. How many pages would he build to make $1,400, Kalia? 6 pages. How do you know that? Yeah, because if we're going to add $700, we have to add 3 pages. I'm not just going to give Javier $700 if I am this company, right? He's got to work for it. He's got to make it 3 pages for every $700. Not yet. Somebody's out. Okay. What next? How much money will he earn if he makes another 3 pages, Adriana? 1,200? What?
Are you looking at the 3?
No, down here. If he makes, so she says 9 pages, yes. So we've added another 3 pages, we've gotten 9 pages. How much will he earn, Adriana? How much money? Judas, how much money will he have earned? 2,100 or 2,100. Okay. Now what? How many pages more does he have to build to make another paycheck, Julia? Yeah, another 3 to make 12. And how much will he earn, Julia, if he makes 12 pages? So don't look at those zeros, right? Those make the numbers huge. 7, 14, 21. What's 21 plus 7? 2,800 or 2,800. Okay, Leilani?
I have a question.
Yes?
How would you say
Not 28,000. I need another zero for that. You mean 2,800?
Yeah.
The reason when I'm filling out a table like this, I like to say at 2,800 is because remember how we said like a fraction is just a thing? It's the same thing with hundreds. So if I'm not paying attention to these zeros, I can just count by sevens. So I can say 700, 1,400, 2,100, 2,800, and then I'm just counting by sevens all of a sudden, and the big huge numbers don't scare me. Okay? Yes, Davian. Okay, next. How many pages should he build next, Davian? 15. And what will his paycheck look like after 15 pages? 3,500 or 3,500. Adriana, you have a question? No? What? Do you know the next number for pages? What is it? 3, 6, 9, 12, 15. Mm-hmm. Sit down. Yes. Love your enthusiasm. But hold on. How much money does Javier need? How much money do you need, Javier, to buy that car you want? Yeah, have we found that value?
Yes.
Have we?
Yes.
So how many pages do you have to build, Javier? 18. How many web pages will Javier need to build before he can pay for the car? We're going to use complete sentences and write Javier will need to build 18 pages. Okay, turn the page. You're looking at page 39, exercise 1. Yes. Not these exact problems, but yeah, ratios are on your homework. Mm-hmm.
Are you recording?
Yes. Okay. Okay, so exercise 1. What's our ratio? What's the ratio, Leilani? 2 cups of cornmeal. Whoop. 2 cups of cornmeal for every 9 gallons of water. So what's the first thing I can write in my table, Vivian? 2 and 9. What do I do next, Julia? I would add 2 on this side. What do I add on this side? 9, right? Just use the ratio to move down the table. 2 plus 2 is? 9 plus 9 is? When I point at the box, you tell me what goes there.
6, 27, 8, 36, 10, 45.
Beautiful. How many cups of cornmeal should be added to 45 gallons of water? Now we can just use our table, right, Ricardo? What do we find?
45 gallons of water, look to the left of it, and it's 10.
Yeah, we found 45 gallons of water right here. So we just look next to it and we know we need 10 cups of cornmeal. Yes. Question? No? Part B says Paul only has 8 cups of cornmeal. Only has 8. How many gallons of water should he add if he wants to make as much cornmeal juice as he can, Michaela? 36. 36 what? Gallons. How did you know that? I can hear you. You're whispering. need to hear you all the way across the room. Fake it till you make it. Aw, come on, Michaela. You need someone to help you out? Kevin, help her out. How do you know that for 8 cups of cornmeal, I need to add 36 gallons of water? The chart? What about the chart? Help him out, Rocco. What do you see on the chart that helps you?
Well, I mean, numbers that, that are multiplied, well, not multiplied, we actually have multiplied by 2.
Okay. Do we multiply 2 or do we add 2?
Add 2.
Yes, we add 2 as we go down the table. Okay, so if Paul only has 8 cups of cornmeal, where do we look? Do we? Yes. Do we?
Okay, so you look at the 8 pot,
Yes, you find 8 for cups of cornmeal.
and then you look to the other side.
Boop.
36.
Ah, I see. Awesome. Okay, so then for part C, what can you say about the values of the ratios in the table? Are the ratios equivalent? Are the ratios equivalent?
Yes.
Yes. So what can you tell me about the values, Persephone?
For every 2, there's 9.
Yes, that's the ratio. How about the value? What can we say about the values, Dasani? They're all equivalent, they're all equal. Right? Our ratios are equivalent, which means they have the same value. The values are all the same. And what value is it that every single one of these ratios shares? Dewey? 2/9, right? Because if I write 4/18, I can reduce it to 2/9. Can I do that for every one of these fractions I end up with?
Yes.
Yes, because every ratio is equivalent in our table. The values are all the same. They're all 2/9. Javier. Okay. Let's move on to exercise 2, page 40. I'm going to read it. Follow along with me. James is setting up a fish tank. He's buying a breed of goldfish that typically grows to be 12 inches long. It is recommended that there be 1 gallon of water for every inch of fish length in the tank. What's the recommended ratio of gallons of water per fully grown goldfish in the tank? We're going to complete our table to answer the questions after it. Let me move this down. And Adriana, can you complete our table on the board? Go ahead. No, you're going to go up to the board and complete it for us. I'm going to toss you this marker. You ready? Sorry, that was my bad. I'm a bad thrower. Okay, go ahead.
Well, I know that 12 equals 1.
Yes.
So it's 12.
Oh, hang on. Now this says number of fish, not how long the fish is, right?
So I know 1 fish equals 12.
Yes.
1.
Yes.
And then we know that for every gallon of water.
Mm-hmm. For every gallon of water, hang on, how do you know how many gallons of water to add?
For every inch.
For every inch. So with 1 fish, how many inches do you have? 12 inches. So you need how many gallons? 12. Perfect. Now, I'm going to go ahead and write that as well. Wow. Sorry. Okay, go ahead and fill in the rest of our table.
So we're going to add 1.
Mm-hmm.
2.
We add 1, which gives us 2.
And then we're going to add 12. 24.
Yes. We add 12 again, right? Which gives us,
36.
mm-hmm. Uh-huh. And then 5 gives us, good job. Good job, Adriana. Okay, so I'm going to fill it out as well. You can erase the board. Yes. Okay, so Adriana said we added 12 down this side, and on this side we added 1 at a time. We add down the chart, down the table. Let's look at part A. What size tank in gallons is needed for James to have 5 full-grown fish, Kalia?
60 gallons.
60 gallons. How do you know?
Because the table says like for every 5 fish there's 60 gallons.
Because our table tells us 5 fish is 60 gallons. How many full-grown fish can go in a 40-gallon tank? Now, is 40 gallons on our table, Judas? Is 40 gallons of water on our table? Do we have a box that says 40? Look at your table. We have a box that says 40. We have 12, 24, 36, 48, and 60. Do we have 40? Where?
48.
Okay, we have 48, but is that more than 40? Yeah, so no, we don't have 40 written on our table. If we did, where would it live? Would it go here?
No.
Would it go here? Ah, yes. Somewhere in between 36 and 48, there would be 40 gallons. So how many fully grown fish can go in a 40-gallon tank? Wesley, help us out. 3. Okay, because if we put any more than 3, we need more than 40 gallons of water. Okay, 3 fish. Now part C says, what can you say about the values of the ratio in the table? Does this question sound familiar? It should. What can you say about them, Davian? They're all not equivalent, they're all equal. Yes. So equivalent means equal in value. So the values are the same. All of the values are the same. Okay. Let's go ahead and move on to page 43. Additive and multiplicative ratio tables. Multiplicative. Say it.
Multiplicative.
Good. Okay. Track me. Persephone, please read the exploratory challenge for us on page 43.
Imagine that you could make a fruit salad. For every quart of blueberries you would like to put 3 quarts of strawberries. Create 3 ratio tables to show the amount of blueberries and strawberries. You need to make fruit salad or gallon numbers.
Good. Okay, so we have tables 1, 2, and 3 made for us already down here. And it says, table 1 should contain amounts where you've added fewer than 10 parts of blueberries. Okay, so less than 10, single digits. Let's make it easier on ourselves and just start with 1. Okay, now table 2 should contain amounts of blueberries between 10 and 50. So what should go in between for these 3? Julie?
10, 20, 30.
Yeah, let's just count by tens. And table 3 should contain amounts of blueberries greater than or equal to 100. Okay. Yes, ma'am. It's okay. Okay, so up here for table 1, if I have one quart? Yes, 1 quart of blueberries. How many quarts of strawberries should I have? Judas, how many quarts of strawberries should I have if I have 1 quart of blueberries? You can look back at the problem if you need to. What's the ratio? Can you read that underlined part for us?
For every quart of blueberries you have, you like to put in 3 quarts of strawberries.
Yeah, so our ratio is 1 to 3. Yeah, for every 1 quart of blueberries, you put in 3 quarts of strawberries. So if I have 1 quart of blueberries, how many strawberries do I have? How many quarts? 3. What if I have 2 quarts of blueberries? Vivian. 6 quarts of strawberries. How about 3 quarts of blueberries? Say it.
9.
4 quarts of blueberries?
12.
And 5 quarts?
15.
15. Okay. Now for table 2. Can I count by 3s again?
No.
Okay. Leilani, explain to us why or why not. Can I count by 3s for my quarts of strawberries? Okay, what do I start with?
3. And then back to 0.
Oh. She says count by 3s and then just add zeros. So then what am I really counting by? No?
30.
30s. Okay. Plus 30 all the way down. And yes, you're right, 10's on this side. Now let's pause before we move on to table 3. Do you see any other relationship between the numbers in our tables? I'll give you a moment. Look at the table. Any other relationships? Okay, Leah. Yes. Yes, which makes it counting by 10s now. Any other relationships we see, Jordan?
That the table 1 is kind of the same as table 2.
Sure. Table 1's kind of the same as table 2. What's the same about them?
They're both.
Javier is just dying to answer. Go ahead, Javier.
Table 1 is by low numbers, lower than.
Okay.
It's by 1s,
Mm-hmm.
and then table 2 is by 10s.
Yes. What patterns do we see within a table? Adriana. We see just 1 digit? No, we don't. Sissy?
Okay, so on the 10s, it's basically like you're doing 1, 2, 3, 4, 5, but you're just adding a 0.
Yes, we did say that. We did say that. We're going to get it, you guys. There's another relationship. Persephone. Ah, nope. Liliana. Woo! There it is. If we move across the table, we're multiplying by 3. If we move down the table, we're adding 1 or adding 3 on this side. If we move across, we're multiplying by 3. How about over here? Same thing. If we move across the table, we are multiplying by 3. So what do you think is going to happen in table 3? If I have 100 quarts of blueberries, how many quarts of strawberries do I have? Because if I move across the table, I can multiply by 3. So let's go ahead and fill in the rest, counting by hundreds. What goes here? And here?
900. 1,500.
Okay. Let me ask you a question. Just by looking at our three tables, if I say I'm going to use 121 quarts of blueberries, how many quarts of strawberries will I need? Itzel. No, remember our value, what we're doing to find how many strawberries, we multiply by. Tony? 363. Because 1 times 3 is 3, 2 times 3 is 6, and 1 times 3 is 3. 363 quarts of strawberries. So can I find any value for strawberries if I have the value for blueberries? Uh-huh.
Yes.
How? What do I do? Kalia.
You multiply it times 3.
So you just multiply by 3. Now, what if I wanted to go the other way? What if I did not have these values and I wanted to find them? What would I do? Julie? Divide by 3. If I'm going the opposite direction, I do the opposite function, I divide. Or operation, sorry, do the opposite operation. Okay, turn the page. There are some questions about our tables. Part A says, describe any patterns you see in the tables. What patterns did we find? Jeffrey, what patterns did we find in our tables? We multiply by 3 across rows. Okay. Did we add going down the columns? We did. And we added down the columns. So when you have a table like this, where you can multiply by a value to get the second value, that's called a multiplicative ratio table. If, for example, you have a table with the ratio 5 to 7, if I keep going, I'm going to get 10, 15, 20, 14, 21, 28. Can I multiply something by 5 to get 7? No. Can I multiply something by 10 to get 14?
No.
Is this multiplicative?
No.
Is it additive?
Yeah.
Yes, I'm adding 5 every time and 7 every time. This is an additive
That's cool.
table. Okay, so part B, how are the amounts of blueberries and strawberries related to each other? How are those amounts related to each other? Well, kind of already answered that question. Okay, so tell me in a complete sentence by rephrasing this question, Julie, how they're related.
They're related because you can
Multiply
multiply by
what?
blueberries and strawberries.
Yes, blueberries. The number of blueberries times 3 equals the number of strawberries. Okay, so how are the values in the blueberries column related to each other? So moving down the table like this, not across. Sissy.
The value, okay.
It's okay.
The value in the blueberries are related to the strawberries because you just added.
Oh, no. How are the values in the blueberries column related to each other? So like this.
They're all by 1. You're adding
I'm counting by,
1.
yeah, so I'm counting by 1s in the first table, but I'm counting by 10s in the second table. So how can we sum that up in one sentence?
In the first table, you are counting by 1. In the second table, you are adding a 0 and counting
Okay.
by 10.
What if I say we're adding down the table by numbers equivalent to the ratio? Because 1 to 3, which was our ratio, is equivalent to 10 to 30, which we used in the second one. And in our third table, we used 100 to 300. We added as we went down. So how are the values of the strawberries columns related to each other? Same thing, right? Same exact thing. We're adding by a value equivalent to the ratio, or by the ratio itself in the case of table 1. We added by 3s. If we want to determine how many quarts of strawberries to add if we have 7 quarts of blueberries, how can we use table 1 to help us determine how many to add? Brianna, how can I use table 1 on the previous page to figure out how many strawberries when I have 7 quarts of blueberries? Look at your table on page 43. How do I use table 1? Can I draw another row? Yeah. What could I write? Okay, Leah, could I draw another row on table 1? I want to know how many strawberries if I have 7 blueberries, quarts. So what can I do, Wesley? Yeah, put a 7 for my blueberries value, use the same factor of 3, and I would get 21 quarts of strawberries. So use the multiplicative factor, which is 3 times 7, 21 quarts of strawberries. Yes.
Isn't QT the abbreviation for quarts?
Yes. Yeah, QT, this is the abbreviation for quarts. Okay, and then move on to part F, which is at the top of page 45, above exercise 1. It says if we know we used 70 quarts of blueberries to make our salad, how can we use a ratio table to find out how many quarts were used? What would we do? Dewey. Trust your gut, be confident. What would we do? Find 70 on the table? Absolutely. We can extend our table. We'd use table 2 where we counted by tens. Oops, wrong paper. And we would extend it, right? By 2 rows. And there's our 70 quarts. How do we find out how many strawberries? Davian, how do we find out how many strawberries if I have 70 quarts of blueberries? And what do you get? What's 7 times 3? Can I just add a 0?
Yeah.
Absolutely. 210 quarts of strawberries. Okay, so look at exercise 1 on page 45. The following tables were made incorrectly. Find the mistakes that were made, create the correct ratio table, and state the ratio that was used to make the correct ratio table. So you're going to look at the relationship between hours and pay and find out where the mistake or mistakes are. Correct them and then rewrite the table correctly over here and the ratio for the table. Okay, I'm going to give you 3 minutes to work in pairs. So work with your partner at a level 1 and go. How do we get from 3 to 24, Shay?
8
8
times 8.
times 8. There we go. 3 times 8 is 24. Is 5 times 8 40? Yes. Is 7 times 8 52? Whoa, no, it's not. What is 7 times 8?
56.
Is 9 times 8 72?
Yes.
Yes. So we're going to rewrite our table. Marina. We're going to rewrite our table correctly. 3, 5, 7, and 9. 24, 40, 56, and 72. And just so I know that's the one I'm correcting, I'm going to box it. So what's the ratio for this table? Dewey.
3
To what? 3 to 24. Can I write this more simply? Kalia?
Yes, you can write it as 1 to 8.
Yeah, I can write it as 1 to 8 because I can divide each side by 3. Good, now part B. Part B, we have a ratio of blue to yellow. How do I get from 1 to 5? Ricardo.
Plus 4?
But when we move across a row, do we add or multiply? We multiply, right? So how can I do that, Adriana? I can multiply by 5. I'm going to pause for a moment. There's humming and tapping and chatter. It's really distracting. Thank you for fixing it. Okay, is 4 times 5 8? Oh, no. We got to fix that. What's 4 times 5? Is 7 times 5 13? No. What's 7 times 5?
35.
Is 10 times 5 16?
No.
It is 50. What did they do here? They added by 3 and then 4 and then 5. Excuse me. It's kind of strange. So let's rewrite our table correctly. 1, 4, 7, and 10. 5, 20, 35, and 50. And just because I did change these, I'm going to go ahead and box them. Now, what's our ratio here for this table? Okay, again, there's chatter. I'll wait. Jordan, what's the ratio for the table in B?
1 to 5.
1 to 5. Because that's our first ratio that's correct. And we can't simplify it anymore. Our ratio is 1 to 5. Yes, sir? It should. It should totally remind you of an input-output table because what we're doing is we have a value. We're doing something to it to get another value, just like an input-output. Yeah. So turn to your problem set for lesson 10, which is on page 47